Okay, and we are still doing analytical geometry. So please note down my email address. It's my name and surname @gmail.com. So no space in between, simply my name and surname @gmail.com. Okay, so in case if you have questions after the session, then you are welcome to send me an email. Okay, so during the session, please just make sure that you on mute and your videos are off. And also we'll have questions at the end of an example or exercise. And you can send me an email after the lesson. Okay, so you can send me an email with questions relating to the work that we've done. If you still don't understand, then I'll try to explain again. And then also we only have maths related questions in the chat. Okay. So again, just a reminder, I'm using the Siavula textbook, but if you're using a different textbook, it's good because you'll probably have more different questions, and please share different questions that you would like us to try in class, okay? So if you're using a different textbook and you saw a problem that you would want us to try in class, you can send me an email. And then we're also gonna do question papers from the DBE website, okay? So that we practice and we see what sort of questions examiners ask, okay? And if you missed a previous session, or you just wanna review a lesson that you attended, then you can go to Africa Teen Geeks YouTube link, YouTube channel, and then search for your grade and subject, okay? So there's also other subjects like accounting, physical science, so you can look into that. And there's also other videos on career guidance and motivational speakers, so you can check that on YouTube and also follow us on Facebook, Twitter, Instagram. Okay. So in this lesson, we're still doing the same work as we did yesterday. So we're determining the distance between 2 points, the gradient if we're given 2 points, or relationship about parallel or perpendicular lines. And then we also determining the midpoint and using properties of quadrilaterals. It's always good to know the formulas in case if you don't get them. And also the properties of quadrilaterals. So this you have to know, guys. So just to revise your properties of quadrilaterals, your rhombus, your parallelogram, and all that. So you need to know them, okay. It will also be good to know properties of triangles, okay. Okay, this is the problem we were doing yesterday. From the question, we highlighted important points such as AC being perpendicular to BD. And then we also noticed that, okay, from our questions, if we are asked to determine the gradient of a line and we only have 1 point, it's possible. If we have a relationship, for example, we are given that our line AC, it's perpendicular to BD, and we know the relationship between perpendicular lines, isn't it? With regards to their gradients. Okay, so for number 3.1, we used perpendicular lines. The product of their gradients is equal to -1. Okay, so yeah. And how we get the gradient of BD, it's from our equation. Okay, so if we write our equation, in terms of, so if we write this equation in terms of y equals to mx plus c, so we can get our gradient from the equation. Okay, so we managed to do this to get the gradient and using the product of perpendicular lines, which is -1. Okay, and then to determine the equation of AC, even if you don't have your y-intercept, you can just use this equation because you just need your gradient and a point. Okay, so we have a point, which is A. We have a gradient that we calculated from 3.1, and then we can get our equation. Okay, if we solve for y in this equation. And then we also went through number 3.3, which is if the equation of AC. So now we have an equation of AC, and we were supposed to calculate the coordinates of T. And we agreed that at point T, we have two lines which are intersecting. Okay, so we have at point T, we have two lines which are intersecting. So it means the y value of line BD and the y value of line AC at this point will be equal. So the x and y values of these functions will be equal. Hence, we equated our functions. So we equated our function of AC and the function of BD and solve for x and y. Okay. So for 3.4, you were supposed to try 3.4, which we were given that if okay, so for 3.4, we are given that we have a kite. So as soon as they specify that ABCD is a kite, then it means we can use all the properties of a kite. Okay, so we are allowed to use the properties of a kite to solve our problem because it is stated. They didn't ask us to prove, they said it is a kite. Okay, so this means, so if ABCD is a kite, then we can use properties of a kite. Before we didn't know the what shape it was. So we just knew that it's a quadrilateral, but we didn't know if it was a kite or parallelogram. But now that they've stated we can use properties of a kite. Okay. So they're stating it's a kite and AB equals to AC. So in that case, if our AB equals to our BC, it means the length from B to C is 15. Okay. So this is 15, this is 15. Okay. And then we also so from properties of a kite, we also know that we have a perpendicular bisect. So this length, so we also know that AT equals to okay, because we are using properties of a kite. Right then, in this case, we know coordinates of A, we know coordinates of T, but then we don't know coordinates of B. And we're supposed to calculate the coordinates of C. We also didn't know the coordinates of C. But then, because we know that T is in the middle of A and C, then we can use our midpoint formula. Okay, so we can use our midpoint formula to get coordinates of C. Okay. And then if you look at the case of calculating the length of BT, right? So BT is from here to there. And you have a right angle triangle. And if you have a right angle triangle, you can use what? Theorem of Pythagoras. Remember, theorem of Pythagoras only applies for right angle triangle. So if you didn't have a right angle triangle, you can't use theorem of Pythagoras. Okay. So how, how you would solve that is by saying, if I have 2 points, you can get the distance, isn't it? You can get the length from AT. So if you can get the length from AT, you have the length from AB, you can get the length from BT. Okay. And remember your length, to check if your answer is correct, your length of AT and BT has to be less than that of BA. Why? Because this is your longest side. So this is your hypotenuse. Okay, so this is your longest side. So whatever value you get for BT has to be less than 15. All right. And then for the last question, you were supposed to get the radius. And we know that the radius is the distance from the center of the circle to the circumference, or it's the diameter divided by 2. Okay, so if you have a circle that is passing through point BCT, so you have a circle that's passing through BCT. So you have a circle that's passing through BCT. Okay, so you will realize that the length of BC is actually the diameter of that circle. Okay, so if you have the diameter, then you can get your radius by dividing by 2. Okay. So if we go through our memo just to check, I hope everyone understands. So if we go through our memo, for example, in 3.1, you got a mark for writing your equation in terms of y. So this is a mark knowing to solve your equation in terms of y, and also showing the relationship between the radius. And then remember this, you need to substitute correctly. Substitute your values correctly, your negative values correctly. And then 3.3, we agreed that is simply equating the two equations because point T is a point of intersection. And then the X value that you get, either whether you substitute it into the equation or the other one, you will still get the same value of y. Okay, because the value of y at that point, at point T, is the same for both equations. Okay. And then, like we said, for 3.4.1, which is using our midpoint formula, then you get your value of x and y. Okay. And then for 3.4.2, we use our distance formula and our theorem of Pythagoras. Okay. So from 3. Okay, let's go back to okay. So and anchor.
Yes, ma'am.
Yes. Remember they say you have to calculate the radius, isn't it?
Yes.
And the radius is half of your diameter, isn't it?
Yes, ma'am.
Yes. So in this case, if you draw, it's just that here it's not very neat. If you draw a circle from point B, T, C, ne? So it's going through BTC. You will realize that, remember if you had, so if it was, let me try to use a different color. So let's say this was, maybe this was B.
Oh.
I think it's because it's not drawn to scale. That's very hard to see. So then you can see that, okay, so BC would actually be a diameter and then your radius would be half of that.
Okay.
Yeah, because it would just be from the center to the side.
Okay, I understand now. Thank you.
Okay, great. So, do you guys understand everything on this question? So what you will notice is usually in maths, you are given the answers. So the answers are in the question. You just have to somehow find them. Okay, so as long as you know your equations and you know your properties of your quadrilaterals or your triangles, and you can relate them, then you are fine. Okay, so but most of the time the answer is in the question. So they give you hints on how to work it out. For example, we saw that this was actually an answer to number 3.2. They just wanted you to work it out. Okay. So are you guys fine? Can we move to the next question, or do you need me to explain something? So we're using everything that we've learned from previous grades and we're just connecting everything together. Okay. If you still have a question, guys, please send me an email, okay? So if you still feel like you want to go through it again, so if you feel like you want to go through it again and then ask me questions later, that is fine. Okay. So let's try another one. So in this case, remember guys, when you see a four-sided shape, you just know that it's a quadrilateral. You don't know what it is until you prove or it is stated in the question. Okay, so you only use properties of a certain quadrilateral if it is given that it's that quadrilateral or after proving. Okay, so if we look at our question, this is a paper from 2018 November. So from our question, it says you have a diagram. Again, you are given 3 points. So in this case, you are given 3 points. And another interesting hint. So another answer, you have AD. So AD is parallel to BC. So they already hinting an answer. Okay, so we have our diagram. So it's also good to know how to plot your points. Okay, so you have AD, which is parallel to BC. So what do you know about parallel lines? Before we even go to the questions, what do you know about parallel lines? Something to do with their gradient. Remember in the previous classes? Parallel lines. So if we have parallel lines, the gradient of AD So what's the relationship between the gradient? Oh, great. Thank you, Kuzai. So yes, the gradient will be equal. So can you see that you already have an answer before you even work it out? BC. Okay, great. Thank you. Okay, so, and then we continue. BA has an x-intercept at E. Okay, so that's another. So you have BA. So BA, which has an x-intercept at E. And and then what do you know about an x-intercept? What happens at an x-intercept? What's the value of y? So at an x-intercept, your value of y is, thank you, 0. Okay. So at an intercept, our value of y is 0. But then we have a value of x. So which other x-intercept do you see on the diagram? So which other point is the x-intercept on our diagram? Look at the diagram carefully. Point E is the x-intercept. Which other point? Thank you. Point N, great. So this point is also an x-intercept, okay. So going back to our information, they say BD and AC intersect at point M. So you have BD and AC which intersect. Okay, so they intersect at point M. So what do we know about a point of intersection? So they say BD and AC intersect at point M. So what can we do at a point of intersection? So at a point of intersection, it means we can equate no. Remember, point of intersection is not our midpoint, okay? Point of intersection simply means they are meeting or crossing at that point. Yes, so we can equate, so we can say y BD, okay, equals to y AC. Okay, thank you so much, guys, for trying. Remember, point M will only be a midpoint if we are given more information. Okay, for now, simply because they intersect, it means we can equate the equation of y equals to BD and AC. So the x value of of each line and the y values are the same at this point. Okay, let's go to, so it will only be a midpoint if we are given more information. Dishan? Oh.
Yes, ma'am.
Yes,
Can
do
you
you
hear me?
understand
Yes, ma'am.
why
I
it's
understand.
not?
I see, ma'am.
Okay. So only when we have information, enough information, then we can say it's a midpoint. Okay.
Yes, thank you, ma'am.
Okay, you're welcome. But thanks for trying. So it shows that you have done problems and you can see that we also have a midpoint in certain cases. Okay. So from our information, we know that AD, so the gradient of AD is equals to the gradient of BC. We know we have an intercept at point E and also at point N. And we also know that intercept, x-intercept means y equals to 0. And then we also know that, okay, at point M, we have BD intersecting AC and we can equate their equations. Okay, so we're still using, so in our questions, they want us to calculate the gradient. So they want us to calculate the gradient. They want us to determine the equation. And they want us to determine a missing point, okay? And a length. So it means we're going to use the previous equations. Remember the equations we used in the last problem. So we're still gonna use the same equations. For example, if we start with our 3.1, okay, they want us to calculate the gradient of BC. But to calculate the gradient, we need 2 points if we are using this formula. Okay, so to calculate the gradient, we need 2 points. Okay. So BC, let's check our BC. So we have points for C and points for B. So which is great. So we can use this equation. So we can use this equation to find our gradient. So in our case, this will be what? This will be BC. Okay. So remember, whether this is your point 1 or this is your point 2, or you have B as your point 1 or C, it doesn't matter, but you always need to indicate. So please indicate which one is your point 1 and which one is your point 2, okay? So it means when you solve your problem, you need to show first, okay, this is my X1 and this is my Y1. And then you also need to indicate your X2 and your Y2. Okay, and make sure that when you substitute, you don't forget the negative sign. Okay, that's how you would get your 3.1 because we have 2 points, hence it's even 2 marks. So you have 2 points. The important thing is to make sure that you know which one is your point 1, which one is your point 2, and make sure that when you substitute, You don't forget the negative sign. Okay. And then for 3.2, they're saying determine the equation of AD. Where's AD? This is AD. So how are you gonna get the equation? How would you determine the equation? We are looking for the equation of AD. Which of these equations are we gonna use to determine the equation? Remember, we have a point. Do we know the gradient of AD? Because remember, if we're finding the equation of a straight line, this is the equation that we use, okay? Because we have a point and we have a point, and what is the gradient of AD? What is the gradient of AD? Okay, great. So it means if you found the gradient of BC, thank you. So remember in the last equation, you were supposed to find the equation of BC. Okay, so if you found the gradient of BC, then you can calculate the gradient of that. Okay, so from 3.1, the gradient is 4/3. Okay, let's try to do it together. Okay, so let's say this is our 0.1 and this is our 0.2. Okay, so we will have this is our 0.1, our x is 0, and our y is -3. Okay, and then our point B, this is 6, and our y2 is 5. Okay, so Sbatler, you are right. The gradients will be equal, but let's just check our gradient. So you have y2 minus y1, okay, divided by your x2 minus x1, okay. So our y2 is 5. And our y2 is 5 and our x2 is 6. Okay. Then minus our y1 is, so we open brackets, -3. Remember, that's why I say make sure you use the correct sign. Okay. And then minus our x1, which is 0. Okay. So we will have 5 negative times negative is positive. Okay. And then this would be 3 over 6. Hope you can see that this is a 6. Okay. And then you would have 5 plus 3, which is 8, divided by 6. And if you simplify this further, this would be 4 over 3. Do we all understand? Okay, let's go back. Okay. So if you got the gradient for the first one, then you can use that, or you can also use the equation of y equals to mx plus c. Okay. And then you have a point, you have a gradient, you just solve for c, and then you have the equation. So please try the rest of the problems, then we'll continue tomorrow. Okay, so up to so far, do you guys have questions? So you see, you were given an answer in the question. So it's always good to read your question carefully. So any questions? Or just send me an email, guys, okay? And then we'll finish off this tomorrow. So thank you so much for your participation today, and we will continue tomorrow.